Today we're going to learn how to factor polynomials using the greatest common factor, which I'm going to call GCF. The greatest common factor, or GCF, is also known as the reverse distributive property. We create a problem that looks like a distributive property problem. The two steps we're going to work on. We want to find the greatest number and variables that can divide or factor out all parts. When we're factoring, we're trying to break the problem down into its smaller parts. With the exponents on our variables, we want to work on using the smallest exponent for the GCF. I will explain that in more details when we go through the example. When we're finished, our answer will look like this. The GCF will go in front, and then we'll set up a set of parentheses, and what I'm going to call the leftovers will go inside the parentheses. So let's investigate this idea of GCF. So the EX example, we have 16 x to the 5 plus 24x to the 3. So the question we want to ask, what is the biggest number they have in common? And as you can see, I'm already labeling the 8. How do I get to the 8? Well, on the side of my work, I've labeled the 16, and I have written down every combination that can multiply to get 16. 1 times 16, 2 times 8, and 4 times 4. Those are the only combinations that will multiply to give us 16. And then I write down the combinations that will multiply to give us 24. 1 times 24, 2 times 12, 3 times 8, and 4 times 6. So from these two lists, I want to identify the largest number that they have in common. So I notice they both have a 1 and a 1. They both have a 2 and a 2. They both have a 4 and a 4. And they both have an 8 and an 8. So the largest one they have in common is an 8 and an 8. So that's where the GCF comes from. It's this largest number that they have in common in the list. That's where the 8 comes from. What is the smallest exponent on the variable? Let's look at the original problem. x5, x3. Which one of those is smaller? The x3. So that's where the 3 comes from. So when I put those together, the GCF is 8x to the 3 power. Now I need to use that GCF. So the left side, back to the example, is where I've started to use that GCF. I am going to factor or divide that 8x to the 3 out. So 16x to the 5 divided by 8x to the 3. 24x to the 3 divided by 8x to the 3. So that I have the problem set up correctly, the GCF goes in front. 8x to the 3 is in front. When I divide 8x to the 3 out, that's the leftovers is what will go inside the parentheses. 16 divided by 8 is 2. x5 divided by x3, remembering from last week when we subtracted our exponents, 5 minus 3 is x to the 2. 24 divided by 8 is 3. Also remembering from last week, when we divide, we subtract those exponents. 3 minus 3 is 0. That means those x's have canceled out, leaving us with our final answer. Now let's work out the 4 examples at the bottom of your notes.